given the sequence here, we see a pattern. Okay, we are adding 2 from term to term. When your pattern is adding, that's an arithmetic sequence. And the recursive equation, we'll use our function notation. I'll call f of n, meaning the number in the nth position can be found by taking the number in the position before that, the n minus 1 position, and adding 2. And with a recursive equation, we need to get into the habit of saying a starting value. So we will indicate that f of 1, the first number we have, is equal to 2. All right, then we need an explicit equation. Now, at this point, we may have recognized the patterns and know what the explicit equation is, but in case not, I will go ahead and make a table here where I have n and f of n. We'll do 1, 2, 3, 4. Now these numbers are the terms in our sequence, so 2, 4, 6, and 8. And what we want to do is write these numbers using the pattern that we have. Our pattern is adding 2. So instead of writing 4 as just 4, we'll write it as 2 plus 2. And 6 we'll write as 2 plus 2 plus 2. And 8 we'll write as 2 plus 2 plus 2 plus 2. And then we see here some repeated addition. And when we see repeated addition, we'll write that as a multiplication. That's a condensed way that we can write it. So this one, 2 plus 2 plus 2 plus 2, is 2 times 4. And up here, this is 2 times 3. And that's 2 times 2. And this is 2 times 1. So we see here a pattern arising. And so to write our formula, if this number over here is n, we can see that the thing over here is always 2 times some number. Now that number we need to write using the variable. And we see that it's always the same as the number over here in this left column. So when this number over here is 4, that number was multiplied by 4. So if this number over here is n, then over here it will be 2 times n. And that's our explicit function, or explicit equation, f of n equals 2 times n.